Welcome the students of CIP Polytechnic. Welcome to our Zener Diode class. Zener Diode class. Zener Diode. Now in this class we will learn the basic physics behind Zener Diode. Zener Diode has a symbol like this. This is anode, this is cathode. This is always minus, this is plus. Why we use Zener Diode in forward bias? Why we use Zener Diode in forward bias? Why? Why should we use Zener Diode in why should we use Zener Diode in reverse bias? Why should we use Zener Diode in reverse bias? Dedicatedly, we need a diode which can be operated in reverse bias condition. So, why we use Zener Diode in reverse bias? Because of the fact that an ordinary diode has a peak inverse voltage of less than 1.5 volt, whereas a Zener diode peak VPIV of Zener is 1.8 volt to 2000 volt. That's why, if the basic physics is, if we place a Zener diode in reverse bias in a strong electrical field, the electrons, the outermost cell electrons of the semiconductor's smallest crystal lattice atom will gain sufficient kinetic energy from the electrical field. The formula is E is equal to mF. Mass M means the mass of electrons, E is the charge of electrons, electrical field intensity capital E, it is volt per meter. This small e charge is coulomb, M mass in kg. F is the acceleration, meter per second square. Now electron gains sufficient amount of kinetic energy and it will move through the semiconductor. It will gain sufficient amount of kinetic energy and it will move through the semiconductor. First, it will collide with other crystal lattice atom and the at last orbital electrons of other crystal lattice atom on which the nucleus or nuclei, plural of nucleus is nuclei of those atoms has a very less attraction. Those electrons will become free. Now this incident is called avalanche multiplication of carriers. One electrons to two electrons to four electrons, 4 to 8, 8 to 16, 16 to 32. Avalanche multiplication of charge areas. One electrons can generate huge number of free electrons due to this avalanche multiplication of charge carriers, due to the stuck with other crystal lattice atoms. Now those electrons will start to move through the Zener diode. Will start to move through the Zener diode due to the presence of strong electrical field. Now a reverse current will be increases. This incident is known as this avalanche multiplication of charge carriers, and the sudden increase in reverse current happens due to Zener breakdown. This incident is particularly known as Zener breakdown. Due to the effect of Zener breakdown, reverse current will increase, and as a result of that, our Zener diode starts doing the operation. We need a special type of diode that can be used for reverse bias dedicatedly. Zener diode VI characteristics looks like this. This is the reverse bias curve. This is breakdown voltage VBR. This is V. This is I. This is called knee current. Knee current, from which the Zener breakdown. Starting from this knee current, the Zener breakdown starts. Zener breakdown starts due to the effect of knee current. Knee current means starting of the high flow of reverse bias current due to the effect of Zener breakdown. This is the point of Zener breakdown, and after the Zener breakdown, up to this it is minority carrier leakage current. But when Zener breakdown happens, due to the knee current starts flowing and it will flow up to a certain limit. See, every device has some limit. This is I high or IH. Every device has some limit. 1.8 to 2000 volt is the peak inverse voltage of Zener diode. So a Zener diode can maximally can operate in between this current level after breakdown, after the reverse bias breakdown. So it is one type of operational diode that can be used dedicatedly for reverse bias due to the presence of strong electrical field. Now, where are the applications we find in Zener diode? What do you find the applications? Where are the applications you are observing in case of Zener diode? What do you find the application of Zener diode? Especially Zener diode is used as voltage regulator, shunt regulator or series regulator. They use. In this class I am not mentioning this, but remember Zener diode can be used in shunt regulator or series regulator due to its dedicated operation in reverse bias. So Zener diode, you have learned what is Zener breakdown and what is avalanche multiplication of charge carriers. Do you know the Zener diode basic operation? It is like an ordinary diode, but it is used basically. This is the symbol of Zener diode. The anode and cathode. Anode is always connected with negative, cathode is always connected with positive. This is Zener diode. This is basically used in reverse bias. This diode is basically used for reverse bias operation in the lab. So this is our ordinary diode and Zener diode operation. And if you need, today your class is ended. If you need something more from the class, you can email it to me or you can WhatsApp me. I am telling this to entire departmental students. You can email it to me and WhatsApp it to me, no problem. So it will be effective for you. Yes.